what are backends in full stack development? So this is the general circle of full stack, what we're learning, the MERN stack, and it's usually divided into two parts, backend and front end. There's one more thing around how front end talks to the backend, but generally these are the two things which, if you know well, you know full stack well. Some people are simply just backend developers and they don't care about front end. They don't write that code and don't understand it. Some people are simply front end developers. What we're learning here is full stack, which is why we learn both the things. But even if you're good or really good at one of them, it's usually good enough to get a job. What we're discussing in today's video is backend development. I quickly want to share a high level roadmap of the things we need to know if you want to know backend, and then I'll tell you what we're learning this week and what we're learning next week. So we have a high level idea. Backend usually is divided into four parts, or if you know these four things well, you're basically good to build backends of most websites. First one, what we're discussing today, is HTTP servers. The second one is authentication. Let me do a quick check on WhatsApp. Yeah, we're good. Second one is authentication. This is basically how you log into a website, what happens when you log out, things like that. Third one is called databases, which is where your data is stored. And finally, something called middlewares, which I'm not going to explain right now. We'll come to it in mostly the next week. HTTP servers in themselves basically comprise of these five things. Could be more, could be less, but more or less, if you know these five things, you understand how to build HTTP servers and their purpose. What is their purpose? I will share in a few. But request methods, URL route, query params, headers, body, status codes, and this thing over here. So request methods, URL route, these things are what we need to discuss today and tomorrow. And then we have enough knowledge about HTTP servers. This is all jargon. So let's first understand what are HTTP servers, why you need them, and more specifically these three things: client server model, HTTP servers, and Express. Cool? Let's get right into the video. Let's roll the clock back a few years ago when we did not have the internet. What's the internet? It's just a lot of wires and very big companies like Airtel, Jio that sort of own these wires. And they provide an internet connection into your house. You have a router or you have an Ethernet cable, and that cable connects everyone around the world. But before there were these machines, the pre-internet days, we only had machines that existed independently. They could not talk to each other. What does that mean? And why have I written UCLA, MIT, USC here? These are big universities in the US where usually a lot of research happens. And these were sort of the universities where there were big machines and they would run very basic algorithms on it. What are algorithms? Things we did last week. If you remember on Replit, we last week created a counter, right? That lets you count from 1 to 1,000, and you did a bunch of other assignments. These are all algorithms that we ran independently on our machine, or more specifically here on Replit's machine, but we never really let anyone else talk to these algorithms. A little jargony, so let me come back here. MIT, UCLA, and USC, a bunch of other universities, even in India, had big machines that were running some algorithms, machine learning models, let's say, or algorithms that calculate some traffic data. The problem was these machines could never talk to each other in the pre-internet days. So we have big machines, they do some work. What is work? Algorithms like these. A function that runs takes an input, returns an output. That is what is running all day on these machines. But there's no way for someone in UCLA to ask someone in MIT what's running on your machine, or for me in India to run an expensive operation there in the pre-internet days. Today, this is possible. ChatGPT is effectively that. You give it a prompt, that prompt goes to a very expensive machine, which is running a very expensive machine learning model on a very heavy machine. It runs your input, gets an output, and returns the output to you. That did not happen until 1970s, 1980s. Eventually, people realized, and let me just share my iPad here so that we understand this a little bit better. Eventually, people realized you can connect computers with wires. So this is computer number 1 in, let's say, MIT. This is my computer, Harkirat. Now let's say I want to run an algorithm in MIT's machine. I don't have the capability to do it. You could say, Harkirat, you have Replit, you can run it. Yes. But let's say it's a very heavy model that only runs on MIT machines. Let me rename this to MIT. When people realized that you can connect machines with wires, they realized that people can, or computers can, talk to each other. Harkirat can ask ChatGPT's server or MIT's server for something, and MIT server can run that calculation here, be it 1 second, be it 10 seconds, however long, and then the MIT server can respond to Harkirat and tell him, hey, the question that you asked, the arguments that you gave me, this is the output for it. So I give it an input, which let's say in the counter variable is 10. It gives me an output, which is let's say whatever 50, which is the sum from 1 to 10. So we're effectively using other people's machines and asking them to run a function, and I'm giving them the input arguments. So until the last class, this was how I would call the function inputs. It would do something and return something. This was running on Harkirat's machine, or more specifically Replit. Now Harkirat's machine does not need Node.js, does not need npm, nothing it needs. It simply needs, let's say, a browser, and the browser will simply ask ChatGPT's machine to find the sum from 1 to 10, and ChatGPT's machine will return the output. Harkirat can show that in the browser. That's what we'll be doing today. The question is, how do you do that? Like, this sounds theoretically very right, that there is one machine, there is another machine, you can talk to each other. But this is a very complicated process, especially if you have to describe this in code. Like, how do we communicate with each other right now? There is a mobile phone I have, there is a mobile phone you have. I can send you an SMS, and that reaches your message inbox and you can read it. I can do a phone call to you, or I can even do a video call to you. These are ways we communicate when we have to talk to each other, exchange some information, which is not necessarily algorithms. But whenever we want to exchange information, we either call each other or we send an SMS or WhatsApp, whatever. There is a very defined way on how machines or phones talk to each other. There's a very defined what's called protocol, and every phone implements that protocol. If there is an incoming call, this guy needs to show a ringer. If you click on accept, audio should start coming in, mic should take the input and start throwing it on the other side. These are what are called protocols. These are always like a defined set of rules around how two machines communicate. In case of standard things that we do, it's something like this. SMS has a protocol, phone number has a protocol. We don't have to worry about this. Let me just increase the size of the nib here, seems fairly small. We don't have to worry about that, how communication happens there. We have to worry about how communication happens between machines. And what is that protocol? That's what's called HTTP. There are many protocols, by the way. HTTP is the most famous one and the one used in most websites. It stands for Hypertext Transfer Protocol, which don't even worry about what that means. It's a defined set of rules around how machines need to communicate. And every machine that exists out there, if they want to allow this sort of communication, has inbuilt rules on how to handle incoming traffic, how to send out outgoing traffic. Under the hood, there are also like more protocols. If you're in college, you might have heard of TCP, UDP, that sort of HTTP uses. But we don't have to worry about that just yet, or maybe throughout this course. We need to learn how to build websites. We need to learn how that gets us a job, for which you don't really need this, especially if all that you want to do is build websites. So what have we learned up until this point? Machines can now, and for a few years now, communicate with each other. How do they communicate? Through what's called the HTTP protocol. Okay. Now let's dive a little bit deeper into what this is, and more specifically, how you can codify it. How can I write? And let's say this is the MIT machine and this is the Harkirat machine. How can I write some code here that lets Harkirat access an algorithm and get back a response? What is this protocol? What are the rules that it follows, so that I can also write something like this on my own? Cool. So let me share back my screen and let's get into the client server model. Okay. What are we learning now? What have we learned up until this point? HTTP. What we're learning now is what's called the client server model. It's fairly simple. The people who defined this protocol said, whenever you want to communicate between two machines, one needs to be a server, one needs to be a client. In the real world, this is big AWS machines in data centers. And this is either my browser or my mobile phone, my desktop app, anything that's called clients is on the left, and anything that runs the algorithm is on the right. That's called the server. So in my case, this is Harkirat's browser, and this is the MIT machine that runs a very heavy algorithm that I cannot run on my machine. A more real world example is this is the ChatGPT server that runs the heavy machine learning model. And this is my very light, slow, small machine, could be an Android phone from 2010. As long as it has a browser, it can be a client and it can ask the ChatGPT server for an output to an input. Okay. So clients, the big reason to introduce this was there are limited resources in the world or limited very heavy machines that can run models as big as ChatGPT's. And more specifically, ChatGPT does not want to open source their model. That's the moat of their business. They want to charge people to run the model, and hence they will never let you run this directly on your browser. In fact, any big business could more or less be run directly in the browser, but the reason they don't let you do that is they want to charge you, and hence they gate your access. They say, if you want an output to your input, which in this case is a output to a machine learning model, ask my server, I will charge you some cents, let's say, then I'll return you the response. Versus if they just give the algorithm here, one, my machine isn't powerful enough to do it, to run the machine learning model of ChatGPT. Two, they will never do that because that's their moat. They don't want to give out that code. They want to restrict that code to their own servers. So they use the HTTP protocol that allows me to communicate to them. But they make sure whenever there's a request coming, I'm a premium user, let's say, and only then they process my request. If I'm a non-premium user, they won't let me run ChatGPT 4 code, let's say. So that's the general idea behind clients and servers. A client is the browser usually, and the server is usually AWS machines, GCP machines, which are running the backend of an application. What are we writing today? Backend. Where is it running? Usually it runs on AWS machines, GCP machines. The client, however, which is React application, HTML, CSS, JavaScript code, or even native applications, they run on your local either browser or your Android phone, so on and so forth. So that's the difference between client and a server. I'll do a quick check at 7:30. I want to give out a lot of information. I think I'm going fairly slow. So hopefully that is the case. How do we communicate to that? I've already answered this. This is how phones communicate, which is there is a protocol that defines how a phone call should be made and what should the other machine do whenever there's an incoming phone call. Same for SMS, same for video calls. Similarly, we have defined there are many protocols, but HTTP is the most common one that lets clients communicate with servers. And that's exactly what we'll learn today. Now comes the important part, the intricacies of this protocol. How should you as a backend developer write code so that you can accept inputs from this client, do whatever computation you want, and return output to the client? That's what your HTTP server effectively has to do, right? Let me share the iPad again. What does an HTTP server have to do? This is an MIT machine or what's called an HTTP server. It needs to allow anyone, in this case, let's say this is Harkirat's machine. It needs to allow not just Harkirat's machine, it could be one of you guys. It needs to allow anyone to talk to it. When they talk to it, they give it some input. For example, give me some chat. Let's say I have a ChatGPT question. What is 2 plus 2? It needs to accept this input. Then it needs to run its machine learning model, which could take 1 second, could take 100 seconds. Then it needs to return the output, which in this case is 4. So that's what ChatGPT needs to do. And the way it does it is through what's called the HTTP server. Now let me show you this practically on the ChatGPT website. Let me just make sure I clear my history. Don't have the best history. I ask it weird questions at 2 p.m. at the night. So clear ChatGPT history. Okay, good to go. Zoom, share screen, share. This is ChatGPT. Subtle flex. I have ChatGPT 4. This is the browser client I was talking about. This thing on the left, which is running on my machine. The logic that renders this button, and this input box, many of you might know, is HTML, CSS, and JavaScript, which is running inside my browser. That code, even if ChatGPT did not have a backend, even if they only had a front end, Am I sharing the right screen? I think so. Rookie, let me know if I'm not sharing the right screen. Even if ChatGPT did not have a backend, they could still give you this front end. There are a lot of websites that only have front ends. They don't need to have backends. You only need a backend when your application needs to do some communication with the backend, which in this case is you asking a prompt. And when I click on this send button, a request going to the backend server, ChatGPT server, processing and returning me the output. In that case, and this is just one example. Another example is if I go to Instagram. If I go to Instagram.com, all these things that come, oh my God, weird Instagram I have. But the images that come back, people's profile number, the people that I'm following is not stored on this browser. That's why it's very well synced from my phone as well as my browser, because all this data is residing someplace else, which is the backend servers of Instagram or Facebook. So that's how most websites work. They give you some front end, but a lot of personalized data here, which in case of Facebook is your Facebook feed. In case of LinkedIn is all the things that you're seeing is stored in some AWS server, more specifically in a database. And it's just returning it to you based on where you are on the screen. If I go to my LinkedIn, which hopefully is cleaner than my Instagram, it wasn't. Anyways, as I scroll down, you will see more data coming in. All this data is never really in my browser. It comes from the backend slowly as I scroll down, and hence that's the purpose of backend. Like backend started as a very small concept where, okay, there's a heavy, universities were like, I am running this algorithm. Earlier, you had to call me to ask, give me inputs and outputs. Now just use this website. Eventually, people built full stack applications. Social networks came into the picture in 2004 and full stack became very prominent because now people had a way to communicate with each other and whatever. So that's the gist of websites. Small poll here. How are we doing? Good or bad? I think I'm going fairly slow. So I think we should be fine. How's the pace? Good or bad? Like fast, slow, perfect. Okay, most people are slow or perfect. No one is fast, so we're good to go. Moving on to, let me just show you quickly how an HTTP request goes out to ChatGPT. Now, some of you will be perplexed here. So breathe with me for 2 minutes. This is the ChatGPT website. I am just on there. You can go there as well. If you are on Chrome, right click and click on inspect. This lets you see all the HTTP requests that your browser is sending to this website's backend. Very big words. This is the client on the left. This is the server on the right. You send it a request. It gives you back some data, right? How that happens, we will see. But this is similar to calling. I call someone, they pick up the call, and then we talk to each other. Let's see how this happens on ChatGPT. This is the website. Right click, click on inspect and click on network here. The goal of this network tab in Chrome, I'm going to show it again. Right click, inspect, click on network. Try this out. I'm going to wait for 2 minutes. Go to chatgpt.com. As long as you're in Chrome, you should be able to right click, inspect, click on network. Okay. And wait here for a minute. Now let's ask ChatGPT a question. Hi, what is 2 plus 2? Haven't yet asked it. Let me press the button. Oh, you see something here. You see a lot of things here. What is happening, Harkirat? I am sending a request to ChatGPT server, asking it for the answer. They have the model. I'm asking them for the model answer. And hence, if you look at, there are a bunch of requests that went out. Ignore most of them. Focus on this one, conversation. In fact, just put a filter here and search for conversation. You will see it says some complicated things it shows you here. But go to the payload. The second thing here. I'm slowly coming to what this is. Don't worry about it. Just want to quickly show you that the communication is happening. Here you will see I'm sending out a message. And if I keep opening this very complex object, at some point you will see, hi, what is 2 plus 2? This is me sending the request to ChatGPT server. Hey, please tell me the output for this prompt. And then eventually it will return me the response. There are a few ways to do it. Since this is a very long running process, you don't immediately get back the response here. But you see me asking, right? This is me sending out the HTTP request to chat.openai.com / as you can see, backend API / conversation. This is their backend. From the front end, I'm sending a request to them and they are returning me the response, which assume it's the response that they gave me is this. It's not exactly this, but okay. Assume I asked it, what is 2 + 2? This request went out and they returned me 2 + 2 = 4. And I just printed it here. Let's try that one more time. Inspect, network. Feel free to click on clear here and add the filter that says conversation. 4 + 4 ? Send. As you can see, another HTTP request went out. Payload now has a different message, 4 + 4 ? Which is the input that I sent. So this is how I'm communicating with ChatGPT server, and ChatGPT server is doing 10 things. It's checking whether or not I have premium GPT-4 access. It's running the model and it's returning this output to me. That's the basics of how websites work. This is the same for LinkedIn. This is the same for Instagram. If I go to LinkedIn, click on inspect here, click on network. If I scroll down, you will see more requests going out. Scroll down, it's getting me more data. As I keep scrolling down, if I remove the filter here, you see so many requests going on. So all these are HTTP requests. This is how the internet works. And this is how you talk to the backend servers of, in this case, LinkedIn, and in this case, ChatGPT. Cool. Where are we getting? Okay. So we're about to start the intricacies of backend servers. I want to do a quick poll check again, and then we'll basically do 15 more minutes of theory, and then we'll start coding. So quick poll, how are we doing? All right. Good combination of perfect and slow, and 3% feel it's fast. So for the 3%, I would say go to my YouTube channel, and I've basically explained all of this in detail, which is why it feels a lot of people find this easy. But there is this video called the Full Stack Roadmap Part 1. It's also in Discord. Go through it. It's basically extremely repetitive what I'm teaching here. So let's get right into how you write code, how you write your HTTP servers. We've seen enough now. Let's start writing an HTTP server. Before that, let me define a few things. Just like when you call someone, I said there is a protocol. Protocols have rules. The rules represent how requests should go out, how response should come back, how you should send the data, how you should send that this is Harkirat Singh on ChatGPT and not someone else, things like these. And these are some jargon that you will have to, 1, understand, and 2, get very comfortable with when you're coding. Cool? Let's start understanding this jargon, and then maybe let's quickly start coding it as well, so that there's a easy sort of switch between theory and actually coding. New sharing my iPad. This is machine 1, which is my browser. This is machine 2, which is my server or ChatGPT server. I am sending a request to it. What the request looks like is now what we need to discuss. The request has a few what are called parameters. The first one, probably even before that, before we get into what are these parameters that you need to send in the request, you need to know where to send the request. There is a ChatGPT server out on the internet. There is a Facebook server out on the internet. There is also a Google server, let's say. You need to know where you want to ask this question. You have so many servers available on the internet. If ChatGPT is what you want to, like if you want an answer to your prompt, you need to hit the ChatGPT server. Question is, how do you do that? This is fairly intuitive. This is similar to how you visit websites. If you want to go to Google's front end, you type google.com in the URL bar. If you want to go to ChatGPT, you go to chat.openai.com. So all of these sort of front ends and even backends have one very important thing, which is the URL. This is how you identify who you want to talk to. In case of ChatGPT, as you saw, it was something like https://chat.openai.com/backend-API. We just saw this. And then I also sent it some body, which you can ignore for now. This is very important. This is the first thing you need to know. when you're trying to communicate with someone, and this is fairly intuitive, when you want to go to a website, how do you go there? You go to their URL, paste it in the URL bar. Similarly, when you want to talk to a specific backend server on the internet, you need to know its URL. How? Well, how do you know Google URL? Well, you just know it intuitively, right? So similarly, assume for now, you need to know their backend URL first. That's how you know you're talking to the right machine. There are many machines on the internet. All of these have URLs of their own. You need to know which one you need to communicate with. If it's ChatGPT, this is the URL that you need to go to. Second important thing is what's called a route. A route is basically what appears after chat.openai.com. So chat.openai.com and some HTTP in front of it, whatever. This is the URL. But as I just showed you a while back, there was also a /backend-API/ something else there. This is what is called the route that you're hitting. Chat.openai.com, this server can do 10 things. It can run 10 different algorithms. This route basically tells what algorithm I want to run right now. I think it was conversations. So if I want my conversation to be a prompt to be converted, this is the route I need to hit. If I want it run on ChatGPT 4, let's say, then it will be a different route. If I want it to give me my username and my existing conversations, it will be a different route. So these URL plus route is the most important thing when you're talking to a backend server. Let's see this in action real quick. Chat.openai.com. Inspect, feel free to do this on your side. Network. Type something, press enter. Where did the request go? It went to chat.openai.com/backend-API/conversation. So this is my request that went out. This is the URL. This is the route. Two things we understand. This is how you talk to a backend machine. Now you might ask, Harkirat, how is this happening under the hood? We will see. That don't worry about. Even this first request that you're sending out to get back HTML is also an HTTP request. If I close all of this, remove all the network logs, and if I refresh this page, and if I scroll to the top of the requests, the first request that went out is this. What URL did I hit? Chat.openai.com. What route did I hit? / which is basically the index route, which is basically nothing. The route is empty. And what did it give me back? If I click on response, it gave me a lot of HTML. This HTML is what rendered this page. So even this request that you're sending out, as you can see here, slides.com/harkiratsingh-3/http server/edit. This is the route and this is the URL. Cool. So we understand this thing. We understand URL, we understand route. There is another thing here called port, which let's not worry about. We'll come to it when we start coding. Cool. I think this is a decent checkpoint for us to start coding. We understand enough now to write a basic backend server that you can go in your browser from itself. Like I can go to a URL here and it gives me back, let's say, the sum from 1 to 10. So question for you, all of you is, write a backend server that on the /route returns the sum from 1 to 10. That's the question we need to codify in Node.js right now. Okay. We will get to all these other things, but let's code a little and then we'll come back to the other things as we need them. For now, assume we're back in 1970 and you've written a very nice algorithm that calculates the sum from 1 to 100, and you need to expose this to everyone in the internet and you need to write the code for it in Node.js. Cool. Move a little bit forward. Structure of a Node.js application. We'll come to everything else soon. Structure of a Node.js application. I think most of you know this. The first thing you need to do now is make sure you have